nasionalismenya, utamakan keluhuran budi, amalkan ilmu dengan kompetensi, berikan yang terbaik, selalu yang terbaik, sebagai karya baktimu. Teruslah berjuang membangun Indonesia sejahterakanlah bangsa dan negara. Teruslah berjuang membangun Indonesia sejahterakanlah bangsa dan negara. PII Persatuan Insinyur Indonesia. Insinyur Indonesia senantiasa menjunjung tinggi integritasnya, bekerja sungguh-sungguh dengan semangat profesionalismenya, utamakan keluhuran budi, amalkan ilmu dengan kompetensi, berikan yang terbaik, selalu yang terbaik, sebagai karya baktimu. Teruslah berjuang membangun Indonesia sejahterakanlah bangsa dan negara. PII Persatuan Insinyur Indonesia.
Ya, Assalamualaikum warahmatullahi wabarakatuh. Ya, selamat sore bagi kita semua. Yes, ladies and gentlemen, good afternoon. Firstly, we would like to say apologize for the technical issue when we are during this webinar. But by the way, we will start first until to waiting for this Secretary General of PII. So, Mas Imam, can you please share the timeline for our webinar today? Then we'll following by Indonesia IMNE and PI IMNE. Thank you. Okay. Then the next rundown is greeting from our the president of the Institution Engineer of Indonesia, yeah, Dr. Insinyur Dani Sumadilaga IPU ASNN ACPE. Mas Imam, can you please rewind?
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good day, everybody. Dear keynote speaker, Insinyur Bambang Guritno, speaker, Mr. Hain Dezong and Khalid Salim, steering committees and organizing committee of this international webinar, as well as all participants who attend this such great event. We now come to the era where Indonesian engineers have been massively involved to contribute more in the various infrastructure development. And we found that Persatuan Insinyur Indonesia, as a reputable professional organization, has been trying to improve their engineers' competency as well as working together with the ministry and private sector, basically the user who are employing and utilizing our engineers. Nowadays, the engineers think what should be done to give added value, optimization, effectiveness, and high quality to the whole process from project initiation, planning, execution, all the way down to project closeout. We understand there is one concept which has been implemented globally, namely value engineering concept. Value engineering is an organized, systematic approach to providing the functionality required for a system or project at an acceptable cost. The reason why we need value engineering in our investment both as clients and engineer as follow. One is to achieve the vision and mission. Second, improving Indonesian competitive capabilities in terms of construction, manufacturing, etc. Third, simplify the decision-making process. Fourth, reducing risk in a project or in a system. Fifth, optimizing costs in achieving effectiveness. Countries that have done value engineering formally and in advance, such as Japan, India, Malaysia, Hong Kong, Singapore, Australia, America, Saudi Arabia, German, Dutch, and several others. Value engineering can be used in various sectors and areas such as industrial engineering, mechanical engineering, manufacture, construction, chemical, and others. Ladies and gentlemen, our distinguished speaker and participants. Through this international seminar on the value engineering hosted by SHIPS, the Institution of Engineers, PIE, we would like to hear expert technical experience through fundamental of value engineering, case study, as well as interactions amongst engineers during the question and answer session. We also like to extend the invitation to not only engineers, but also clients, non-engineers who are investing in infrastructure and manufacturing sector. You may find this value engineering concept will be very valuable for you to ensure you will produce infrastructure and assets with high quality performance function with optimized cost. And last but not least, on behalf of the Institution of Engineers Indonesia, PIE, we thank you to Center of Engineering and Industrial Policy, SAPES, steering and organizing committees who manage to organize this international event. Wish you all having an enjoyable and decent seminar. Have a great one. Good day and wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you, Pak.
Okay. Thank you very much for the chairman or the president of the Institution of Engineers Indonesia for the opening remarks of this today webinar. Then actually the next is a keynote speaker from the Secretary General of the Institution of Engineers Indonesia. By the way, we will waiting for him until he able to join of this today's session. Then the next I would like to call our distinguished speaker from International Value of Engineering Practice, Mr. Han De Jong. He already joined us on this session? Pak Frankie, would you like to accompany me for this session?
Hi, yes, thank you, Pak Prastiwo. I'm just going to introduce Pak Hein quickly, if you don't mind. If you can see my screen. So thank you all the participants for your patience and bearing with us. So let me introduce Pak Hein for a bit. He's a value manager and value engineer and facilitator at Value FM. He has his background is in environmental engineering, and he's been working on this. His career spans more than 30 years, and he has been focusing on this value engineering with Value FM in the last 12 years or so. So he's going to share with us today his experience, knowledge, and some examples. Pak Hein De Jong, please, if you may.
Yeah, thank you, everybody. Thank you, Pak Frankie Ken. Thank you, previous speaker. Let me share the screen. Someone is sharing the screen. I think it's you, Pak Frankie. Can you release the screen, please? Yeah, there you are. Share screen. I go to Miro, share. Here we are. So I'm going to tell you a little story about value engineering. Some of the good things were already said. So you will hear some noise in the background. It's thunder here. You're used to it, I think. Let me start. So what is value engineering? Well, this is a very short summary of what it is. It is a design optimization process. Any design can always be optimized. Value engineering is a specific process to do that.
Apology to interrupt, Pak Hein, but I think your voice coming a bit soft.
Whoa. Is this better like this now? I move closer
It's
to
better,
the screen.
but still relatively soft. But I think if you may proceed.
Yep. So is this better as it is now?
Better, but still relatively soft. But if there is no other way to improve, I think it's all right.
No, I don't think so. Let me see. Audio settings. Microphone. I'll put it louder, 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 louder. Suppress background noise. Is it going better now? I hope.
Yes,
Let me.
much better.
Okay, let's continue. Never mind the storm. So it's a design optimization process. Any design can be optimized in industry and government with value engineering. A good design in is an optimized design out if you use this process. Also true, if you put garbage in, it's garbage out. Meaning, we want a good design to optimize, and else the conclusion is just, it's a bad design. There are about 100,000 value engineers around the globe. 1,000 are black belts, those are the heavyweights, and there are 100 trainers. Okay, like PE, there is organizations in Belanda, in German, USA, Malayu, Hong Kong, United Kingdom, Australia, Canada, and now PEE, which have communities of practice for value engineering. And those are lively places where people share knowledge, make each other enthusiastic, share examples, etc. It's used in mechanical, chemical, oil, gas, civil, architecture, you mention it. And it's used on many levels, from meteor, junior a little bit, not so much. Meteor, yes, senior, definitely, to the higher senior level. So the trainings we give is for meteor and senior engineer. Project managers, project engineers, system designers, architects, controllers and planners, those are the fellows who can benefit from value engineering. So I think PE is a good place for us. In the last years, 2018, 2022, we did 30 value engineering studies, 12 trainings, had more than 80 people in Binamarga. I started my project in Binamarga 4 years ago. We've got 84 alumni from the VM1, that's the yellow belt, green belt, VM2, black belt, VM3. If they get more than 400 hours, they can become PVM, which is a practitioner in value management.
Yeah, okay.
Okay, sir.
Yeah, can I continue? Can I continue?
Yes, go ahead, Pa. Sorry.
Okay, PVM International Certificate, valid in Europe, and you can cross-certify with the United States. If you work in a multinational, for example, they will know value engineering. And if you have more than 10,000 hours in value management, you can become the trainer. Meaning any trainer in TVM certificate is a very experienced fellow. The ESP program we did, it's a program of a lot of projects. It paid itself back about 500 times or more. So actually, Binamarga gets this all for free and earn a lot of money. That's a good deal, isn't it? Not many trainings can make this so clear as we can, because we save money. We have made a standard. The standard is a Pvm. You can find it on the internet. You can Google for it. Number 4, Pvm 2022. It's about statement of work value engineering. If you ever do a project within Binamarga, this is your chance to change the specs maybe, or challenge the scope, because you say, let's do with value engineering. I will explain later what it is exactly. Value engineering is one of the value improving practices around the globe. There are many. It depends upon the company how long the list is, but the list is seldom more than 15 or so, and most often value engineering is one of them. So if you want to know what value engineering is, I will explain to you. But first, before we say what is it, I want to tell you why people want it. I'm currently doing a training for value engineers, and this is one of the exercises they must do. And it is about, why do you love value engineering? Why do you need it? Why do you pay for it? And why do we design performance? Why F times P is function and performance from a system, because value engineering is very much about functions and about performances. So what do the people in Binamarga say when they say we love value engineering? Well, they say we want to share our experiences with each other. We want to create a good infrastructure. We want to create a good infrastructure. We want to give value to our life. That's why we are doing the work we are doing. We want to advance the country, contribute to the community. It's our duty, because we love success story. We want to get a well-earned good image. We are proud to build. That's why they love it, by their heart, emotionally. And why they need it, because they want to give better lives for the next generation, or to build infrastructure that meets the standards, present and future generations. Why do you pay for it? Well, we pay for function and performance because we want to make better service, to build a stronger country and make the supply chain sustainable. Why do you pay for performance in designs? That's pretty simple, actually, because you have a plan. You want to have sharp thinking, you want to deliver outcomes, you want to create growth. So I think that you understand when you speak with someone from Dinamarca who has just done the training, is going to tell you quite a story. And the story starts with the result of a VE study. And this can be one of the results of a value engineering study. You can see there's performance on the x-axis on the bottom, and there's cost on the y-axis. In 2016, 2020, 2021A, and 2021B, there were value engineering studies on one topic, flyover skip. And in 2016, the value score, the performance of the bridge was about 80. How you calculate it, I'm not going to tell you today, but it is the performance of the system, everything included. The lifecycle cost was high. So we did a value engineering study, or they did, and the price went down, optimization number 1. And then we did another optimization, and it went even down further from 280 to 230 approximately, and one was even at 200. So another saving with a higher performance. So this is very typically value engineering. Can we make it cheaper, and can we get a better function and performance? Or if we add a little bit more money, can we get a way better performance? Complete a little bit of you raise your hands, but please wait until I'm finished. Another way to get results is like this, a table with a long list of ideas. This is apparently in a food factory, process industry, and you do your value engineering thing, you investigate, you prioritize, etc., etc., etc. And in the end, you have a list of ideas with high value or positive value, or maybe, we don't know yet. This is the kind of outcome that you want to see from a value engineering study. Lots of optimizations, sometimes in the form of a complete scenario for a topic, sometimes in the form of a list of good ideas to implement. Okay, so how does it work? This is how it works. There's a pressure cooker, which is a room. And in the room, there's a facilitator with a timer. There must be a multidisciplinary team. There must be experts, subject matter experts. And the multidisciplinary team includes everybody who's closely related to the system, the stakeholders. We want goals. When is the project a success? What is the outcome? When is it good enough? We want a design, a good design preferably. And we want a structured process. This is one of the powers. This optimization is a structured process with all those people in limited time. That's why it's called a pressure cooker. And in the end, there's a value philosophy. And the idea of value philosophy is different rules in the design give different outcomes. So you try to look at the project, at the design, from a different point of view you did not do before. If you would do the same before, you would get the same outcome. There are 6 Q&As. No. Wait, I moved that. So you must add energy to the pressure cooker, which is your time. The people must invest 1, 2, 3, or 4 days, depending upon the size of the project. Energy and time. That's what it takes. And then you have a pressure cooker, the pressure will come there, and the facilitator is going to help you through a process. So what is the process? The process is very simple. You prepare your sessions, and then in the workshop, you share all information that everybody must know. Then you do function analysis, an extremely powerful tool to explore all functions of a system. And there are some specific value engineering tools which make it a very, very intensive exercise. When you've done all the analysis that are needed, including cost analysis, risk analysis, issue analysis, stakeholder analysis, function analysis, performance analysis, cost allocation, etc., you will have a lot of ideas how to improve that system, because you have all the information, you've analyzed all important things, and you can go to idea creation. And usually there are 100 or 200 sometimes more ideas to improve the system. Well, 400 or 300 is really too much. So you select the best ideas that are feasible enough to investigate further in the development phase. You work it out until you know probably know what the new performance is going to be, what new costs are going to be. Then you do evaluation and presentation of the ideas to the decision makers, and you draw your conclusions. Conclusions can, for example, be, we have 4 points where we want to change the existing systems, whether it's a road or a bridge or a chemical plant, everything is good. As long as it has a function and costs money, you can value engineer. And then you must go to implementation of the ideas. That's the final step in the value engineering process. So you get the recommendations for the implementation. So from start to finish, in the start you start with a design, hopefully a good design, and in the end you have implementation planned for optimized ideas. I told you already, this is for oil, for gas, for infrastructure, for government, non-government, for profit, for non-profit. Everybody who spends money on systems is capable of using value engineering. So what is the definition of value? It's pretty simple. It's function times performance divided by cost. Function, performance, and cost. So you can add functions to a system. For example, the phone can have a camera. That's how they improved it. Or the performance. For example, the battery life of a phone. And the costs are clear. Those are the life cycle costs. So that is investment plus maintenance. And when you have engineered functions, performances, and costs, you can ask the client what he thinks of it, how he values this system. So the value is a little bit subjective, but function and performance and cost, it's very much engineering. Cost engineering, function engineering, performance engineering, including safety, including whatever topic is there in that system. That's actually the summary of the story, I think. Let me see. Yeah, one picture then. Here you see the engineering study we did last time. It is a road on Kalimantan. And here the team is optimizing it. Alvin is here facilitating. I am Alvin's coach. He's getting so far nowadays that he can facilitate studies. Sometimes a bit help of me, often no help at all. So, you know, what you need is a laptop, some clever software, and especially a good facilitator. That is very important. And a good engineering team, because the people make the plan, the people make the results. If you don't have the right people who have ideas or insight in what is really important and what improvements really are helping the system, then you are lost, right? So the selection of the people in the value engineering team is the key success factor. Yeah, I think I've told my basic things. You have had a lot of information now. If you want to take away one thing, well, 2 things. Here's my name. If you want to contact me, great, go ahead. I'm very easily accessible. This is also my WhatsApp number, the 3163266262. And I want you to take away this one. All cost is for function. Well, give that a thought. If you're curious how this may work in your industry, if it can be used to optimize your systems, to optimize cooperation, to find mistakes, to mitigate risk, to do some very complex optimizations together, then value engineering may be for you. That's it. Thank you very much for your attention. Selamat siang, Pak Bambang. There you are. Nice to see you.
Sorry, Pak Diong.
Yeah, Pak.
Sorry for being late, yeah.
Yeah. I was allowed to start before you, Pak. Sorry.
Yeah. No problem at all. No problem at all. Yeah, I've done today. I have started with you. I think 3 or 4 seminars, yeah, with me. Another 2 is coming later tonight. Silakan, go ahead.
Thank you, Pak Hein. Thank you, Pak Bambang. So, apology to all participants here, but we do have to, due to technological issues, we have to shuffle up a bit. So, and Pak Khalid hasn't been able to join us. So, the second presenter. So, what we will do is we will now ask Pak Bambang Guritno, who is currently serving as the Secretary General of PIE, and also serve as commissioner in many of the state-owned infrastructures companies, and previously senior officials at the Ministry of Public Works. So, Pak Bambang, if you may, would you like me to share your presentation from my screen, or would you be doing it?
Can I do myself, please?
Yes, okay.
Okay.
Please, Pak Bambang.
Is it now okay?
Yes.
Okay.
The presentation.
Ini kok stay host ya, okay. Okay. First of all, I would like to apologize for my serious delay, yeah, and the presentation, yeah, my arrival to this room due to my lack of understanding to the technology, yeah. So, good afternoon to everybody, and I think on behalf of PEE, I will say this my appreciation, yeah, that we today have a very important seminar, the role of PEE. I will present the role of PEE in developing value engineering expertise for Indonesian infrastructure development. Maybe these papers will take about 15 to 20 minutes, yeah. But I hope that I can finish quickly. The outline is the spirit of law number 11, 2014 regarding engineering profession, and then second topic is engineering profession transformation after the issuance of the law. And then the professional engineer practice in Indonesia, and then lastly, value engineering for Indonesia infrastructure development. This is the spirit of the law 11, 2014 regarding engineering profession. Yeah, you can see here there are 8 elements. Yeah, which embracing what PE now doing. Yeah. Number 1 is PEA pursuing global competition, yeah, will promote our engineers to enter global competition, yeah. Secondly, public safety and environment. It's very important as a professional that we have to provide expertise to our engineers in order to conduct their activities, engineering activity, according to public safety and environment, ecosystem, environment sound, yeah. And then increasing interest in engineering. This is one of the important thing in particular in the young generation. We promote our kids, our young generation to enter the engineering sector in engineering field. Yeah. In particular, Indonesia, since we have a very large country and then very diverse, so important thing to how to set up the system that will enable other island also out of Java to grow, to develop, yeah, as fast as Java, yeah. And it's very important to develop the universities, training, and then also facilities, yeah, in order to push or to promote, yeah, education system outside of Java, in particular Indonesia, eastern part of Indonesia. And then also increasing the role of engineers in the industry, yeah, and managing foreign engineers, yeah, it's part of the assignments also in the for 2PII, yeah, in order to not to protect our engineer, but also to protect the foreign engineers to practice, yeah, as long as we can do that ourselves, yeah, we have to prepare our engineers to compete with international engineers, yeah. One thing which is very important related to the value engineering is encouraging innovation, yeah. Important part of the spirit, yeah, is to encourage innovation. And this is very related to our subject today, value engineering, which is how to create, how to develop, how to set up, establish, or to make it happen with very efficient, with according to the norm and standard, yeah, engineering standards, in efficient way, yeah, and but it's still safe, still according to standard and sound, environmentally sound. And number 8 is knowledge update. It's very important to engineers, yeah. So the law on engineering demands our Indonesian engineers master various engineering practice, yeah. And value engineering is one of the innovative techniques invented by engineers. This is the history of PII, yeah. PII established since 1952, but actually the Indonesian engineer has been active, very active domestically and also internationally since 1924 and 1916, yeah, where the first Indonesian engineer is born in 1916, but still trained in outside, yeah, in the Netherlands, yeah. And then the role of engineering became more important as agent of change and an agent of development in Indonesia, and recognized internationally also. And finally, in 1952, we set up an organization, professional organization, namely Persatuan Insinyur Indonesia. Then in 2014, the law embraced PII, yeah, give a mandate to PII to execute engineering profession in Indonesia as set up in 2014, yeah. So basically the law itself is a call from the country to our engineers, yeah, gathered in PII to present their contribution by preparing themselves as qualified and competent engineers, be able to advance Indonesia as becoming one of modern competitive nation in the world. There are 3 elements under the law, yeah. Firstly is collective message for engineers, as I mentioned before. And then the law also described that the PIS implementing body of engineering profession. Yeah. And then thirdly, the important part of the law is mentioned or implicitly that the government PIS, the government partner in preparing human resources engineers to support national development. So we oftenly call this as transformation of the engineer, yeah, which the task of the PI becoming very large now. Firstly is accreditation of engineers in education, engineering education in the university, yeah, and then engineers profession program, yeah, what we know as certificate competency engineer. Engineers profession program is conducted by university, but still supported by PII. Yeah. So graduates from university basically is still sarjana teknik, but need to be trained about 1 year to become engineer. Yeah. In this duration, PI take a role to support in the training and the preparing the lecturers, and then also in the providing the industry or factory or place to practice his engineering practice in order to familiarize the practical engineering to the student. And then PE certification system is a process to produce engineer professional pratama, madhya, or utama after examination. Yeah, so basically this is filling out the data of the engineers, his experience, and then assess them in order to determine whether it is he is or she is allowed to become a professional pratama, madhya, or utama. Yeah. And then PIA also has a task to accreditize engineering association. And finally, is the ultimate goal of all professional is to get the STRE or license to practice in order for everybody to practice his engineering expertise. Yeah. And then one thing which is also important is CPD, continuing professional development. For also important, PEE also responsible to look after, to monitor the process of CPD of every engineers under PEE membership. And then lastly is international recognition. Those who have already EPM or EPU, they are eligible to apply international recognition, yeah, whether APEC engineer, ACPE, Asian engineer, etc. This is the roadmap to be professional engineer. Yeah. Since the Bachelor of Vocational degree, and then move up to training, engineering training, what we call it, engineering training is in the university, and then this is the domain of the university, yeah, engineering training, but still supported by PII. And then junior engineer after several years experience, and then becoming EPM or EPU, senior executive professional engineer. and then finally going up to having engineering license, yeah, engineering practice, yeah, the license to practice. And then the international recognition we have is Asian Chartered Professional Engineer, ACPE, Asian Engineer, and then APEC Engineer. This philosophy of professional engineering practice in Indonesia is normal, similar, almost the same with other country also. License to practice in many countries, in Indonesia, Singapore, Malaysia, US, Canada. That is, someone needs to take responsibilities for the engineering deliverables prior to release for implementation, such as construction, ready for construction. Also, as a quality assurance of the works done by engineer, all deliverables should be approved and endorsed, stamped by the professional engineers. Yeah. So, what is the professional responsibility as professional engineer? The responsibility is to comply with technical standard, legal standard, professional ethics, maintain operational status as PE. The capacity is practicing engineering, mandatory to fulfill all obligation, and then professional code of ethics is carry out engineering practice honestly, responsibly, and committed to completing professional responsibilities. This is stipulated in the law, yeah, Article 50 of the law 11, that non-professional engineers practicing engineering and acting as professional engineer can be punished and imprisoned for 2 years or a fine up to 2,000 million rupees. Yeah, every non-professional engineer person who practices engineering and acts as a PE, which causes an accident or the loss of the person's life, can be sentenced, yeah, can be sentenced up to 10 years and fined 1 billion rupees. And then for those who have already STRE, also subject to the law, yeah, if they carry out engineering practice that cause material losses, are subject to administrative sanctions. But every professional engineer, yeah, means that they have already STRI. If they do not meet engineering standards and result in an accident, disability, loss of person's life, can be sentenced up to 5 years and a fine up to 1 billion rupees. This is the responsibilities and liabilities of professional engineers. So, professional engineering practice, they can practice individually or as part of the consultant or contractor company. Yeah. After having STRI or PE license from BAE, they can carry out projects directly from clients. Yeah. They have the same right and obligation as PE who work in the company or contractor, and they can carry out approval or technical documents, even though it is not included in the company internal organization. For those who own a consultant or contractor company, engineers who have STRE can create or can set up or can establish their own company. They can employ engineers and engineering graduates, and all technical documents issued must be approved by engineers who have STRI or license. Yeah. So basically, engineers who have STRI or PE license issued by are equipped with a STRI and PE stamp. Yeah, and this STRI or PE stamp indicates that the PE will provide quality and safety assurance in accordance with engineering codes and standard. Now we come to our subject this afternoon. Yeah, value engineering for infrastructure development. I think Mr. Andy Young already explained a lot. Yeah, value engineering is a recognized systematic approach to providing the functionality required for a system or project at an acceptable cost. Value is, value performance divided by cost. Yeah. Value engineering is the most effective techniques known to identify and eliminate unnecessary costs in the project design, construction, operations, and maintenance. Yeah, of course, I think Mr. Handy Young must be agree to this. Yeah. So the keywords is value, function, quality, performance, and cost. The reason why do we need the value engineering? Yeah, it is very important for investment both by clients or engineers. Yeah. First is how to achieve value engineering is very important in order us to easier, yeah, to achieve mission and vision. Why is that? Because the cost is lower, of course. Yeah, there is no value engineering which creates a more inefficient. Must be efficient way. Yeah. Then second is improving Indonesia's competitive capabilities in construction, manufacturing, oil and gas, mining, operation and maintenance. And then also for project owner is simplify the decision-making process and reducing risk in project or system and optimizing costs in achieving effectiveness. So basically, value engineering very important because it will help us to be more easier to achieve our goals, yeah, vision and mission, yeah, because they will, of course, they need to think, yeah, we need to put effort to think how to make efficient, yeah, in terms of design, in terms of material usage, etc. Nowadays, the engineer think what should be done to present value added, optimization, effectiveness, while maintaining high performance of the product and deliverables by implementing VE technique to the whole process from the project initiation, planning, execution, all the way down to project close out. Then how PIIX to bring this up to speed? Yeah, PII under the PII we have the unit, yeah, call it Center of Engineering Industrial Policies or SAPES, yeah, that will initiate VE community of practice. Yeah, I think the chairman or the head of the chiefs is already in this, also in this room, yeah. And then invite all engineers, professional engineers within engineering college, badan-badan kejuruan, which is about 27 badan kejuruan under PIA, to upskill their competencies on value engineering. And then promote VEs through series of webinar courses and promote Indonesian profession to obtain qualified and certified value management. And finally, also promote these VE benefits to both government and private clients. I think so. As far as I understand, some government office already, ministries already applying the VE management, and their activities, as I heard this Pinamarca already done this, but I hope that it will be enlarged, will be broadened up, to many agencies, government agencies, ministries, etc. Also in the state-owned companies, So as the conclusion, after the issuance of Law 11/2014, BII has an important task in developing professional development, and coaching Indonesian engineers, and the preparation of superior and highly competitive engineers to bring progress, prosperity, and glory of the nation. Engineering transformation mandated to BII must be able to create conducive climate for growth and professionalism. Innovation, one thing, innovation, creative and excellence of engineers, as well as being able to improve engineers' quality of services, deliverables to engineering users or client. Then to whom client, government, private clients are investing in infrastructure and manufacturing sectors, you may find this concept be very valuable to assure the assets, facilities, infrastructures produced with agreed quality performance function with optimized costs. Okay, thank you very much. I think that's all hopefully not more than 20 minutes now. Thank you very much. Selamat sore. And I think we have a discussion session. Okay, thank you.
Thank you, Pak Bambang, and thank you for all the participants. It's very enthusiastic. There are already a few questions, some questions streaming in, but we will have the Q&A session towards the end of this after the third presenter, who I will be introducing now. So just a bit of recap. So Pak Hein has already introduced us to the concept and the practice of a value engineering, which is not just cutting costs and all that, but it's a lot more than that. And Pak Bambang has already shown us that value engineering is not just needed, but it is expected out of Indonesian professional engineers. And PII is currently doing a lot of work in it to facilitate the training and all that in Indonesia. Now I will introduce our third and last speaker for today before we move on to the panelists. Hold on. So our third speaker is Pak Khalid Salim, who's also an engineer in Indonesia already. He's the president director of Arup Indonesia. So expect everyone knows the company. And Pak Khalid himself has been practicing engineering, civil engineering, in the last 25 years, including leading major projects, MRT project, LRT project in Indonesia. So we're hoping that Pak Khalid today will be sharing with us on his experience from the more pragmatic and commercial point of view. Pak Khalid, please.
Thank you, Pak Frank. Can everybody hear me, please?
Yes.
Okay, thank you very much. Assalamu alaikum, salamat sore. Thank you for this opportunity to share my experience, and I would make it, my presentation would actually be looking at the practical aspects of value engineering. So I'll take you through a case study. So I'll share my screen. So please let me know when you can see it.
Yeah, can see.
Okay, thank you. All right, so as I said before, I will be talking about a project and really looking at what you've already heard from other participants of what value engineering is, but I'll take you through the application of value engineering. Just a brief introduction of myself. So my name is Khalid Salim. I'm the President Director of PT Arab Indonesia. I have a background in structural engineering and in particular in design and construction of bridges. Very, very passionate about bridges, and hence my presentation is going to be about a bridge engineering project. So before I start, I think a quick introduction about Arab. So Arab is global engineering firm from the United Kingdom. We have taken a lot of iconic value engineered projects around the world. And some of the examples you can see on the screen, which include the Sydney Opera House in Australia, the Stonecutter Bridge in Hong Kong, which is a cable stayed bridge, the Bird Nest Olympic Stadium in Beijing. All of these projects were where we use value engineering to come up with really, really fantastic solutions. There's some examples here from our current projects and recent projects in Indonesia. So Arab was involved in the Indonesia Convention Exhibition, ICE, in BSD City, and the Menara Astra, which is the tallest building in Jakarta at the moment. Recently, we have completed the master plan of the IKN, or the Nusantara, the new capital city. We've been working with on that for 2 years and have done the master planning and detailed planning. And we are also currently doing the detailed engineering design on one of the sections, underground sections of Jakarta MRT, which is from Harmony to Mangga Besar. So all of these projects are not ordinary projects. That's where you do need innovation, where you do need to apply value engineering concepts. Okay, so value engineering definition has already been put forward to you by other participants. So what I'll like to talk about is the benefits of value engineering. So I think you would have already gathered. So value engineering is used for solving problems. It does reduce costs. It actually reduces time as well. You know, you can finish the project earlier, much faster. It can improve functionality. It can improve quality. You can actually make a project adaptable for future use. So all of this, is where you can use value engineering. And also, we can actually use it for minimizing the environmental impacts of a project and also maximizing the social benefits. So I'll now take you through a practical example of a project, which is from an earlier part of my career, but it's a project which every section of this project we had to apply value engineering, and it actually won 22 awards, which I'll take you through briefly later. But also this project was finished 2 months earlier than the schedule, and we ended up with a cost saving of $16 million. So this is a bus rapid transit project in Brisbane, Australia, and the name of the project is Northern Busway. So some details of these projects, and you can see some photographs as well. This is during construction when the project was constructed. So as you can see, it actually was constructed in a hospital, the main hospital in Brisbane, Australia, and it was over arterial roads, main roads, and operational railway. So the project was a 1.2 kilometer long dedicated BRT, and it is fully elevated. It's on the bridge, so it doesn't go on the normal road just like Transjakarta, but actually it's got a separate alignment and corridor which is elevated, so it's all on a bridge. And then it has a 3-story busway station. So the bridge actually passes through the 3rd story where you actually get on the buses, but then coming from the ground floor, you actually get your tickets and you go on to the 1st floor. And then from there, you go on to the 3rd floor to get onto the buses. The construction cost of this project was $200 million. But as I said earlier, we actually saved $16 million out of that through value engineering. It was done for the Queensland government in Australia, and the contract type was alliance. I think that is something which is not being used in Indonesia, but I would just very, very briefly tell you that an alliance contract is where actually the government, the contractor, and the design consultant become partners. And then they determine key performance indicators. For example, the project should finish in 18 months, or the project should be finished in 200 millions. The scope is very, very loose. So actually, for example, for this project, ultimately we ended up constructing a bridge. But initially, we actually pursued two options: one underground option of a tunnel, and then one bridge option. Of course, the tunnel option was almost 3 times more costly than the bridge option. So hence we used the bridge option finally. This is not a new project, but you will see that if you want, you can actually use value engineering concepts wherever you are. And it's not a new concept. It's been there for quite some time. This project is almost 15 years old. It was constructed from 2007 to 2009, and it's been in operation, or the buses are using it since 2010. So there was a lot of complexity, and hence we had to use the value engineering. As I said before, as you can see from this picture, this particular picture shows what we commonly referred to at that time as the spaghetti or the noodle junction, because you can see there are roads, bridges going all across everywhere. So there were lots of challenges which made this project very complex. Some of those were like, as you can see, there are roads going all over, and the bridge where I'm pointing now, which is, you can see the roof of that bus station, which I mentioned. We'll see a bit more in detail. That's where the project is, but then it's connecting to all sorts of other projects around. So we had to construct it over roads where the traffic was ongoing, and there was more than 1,000 vehicles on that road every day. It is constructed inside a hospital, so it actually, we had to allow for ambulances and other emergency vehicles coming into the hospital 24 hours, all 7 days. So we had to design for it through value engineering, and we had to construct for it as well with all these issues. And then there were lots of services which we will look at in a minute, like the gas, electricity, and power, which actually supply to the hospital here. And we had to make sure that those were protected, and the supply of electric power and water and gas to the hospital was not disturbed during our construction, and there were no accidents, and so that could adversely impact the hospital. As you can see, these projects which is now completed, actually they were being built, so we had to make sure that we had to integrate our project, which is here, with these at the same time. So we had to do a lot of coordination with these other projects where other design consultants and other contractors were working to make sure that the traffic is not disrupted and the construction can finish on time. And one other thing was, like, although it's a bus rapid transit project, we were asked to make it compatible for light rail in future. So we had to design and construct it in such a way that it could easily be converted into a light rail in future from a bus rapid transit. So what were the challenges and why we had to use value engineering? So as you can see, the left-hand side, there's a drawing cutout which I put there. It shows the original concept, which was done by others, where you can see a foundation, which is like a spread footing or pad footing. And, it has some ground anchors to make it stable, because as you can see, the bridge above is actually asymmetric. So the column is not in the center of the bridge, which means the bridge is continuously trying to fall over on the road here. And then you can see some services here. But if we had used this concept without value engineering, we would have to actually relocate all of these services which are supplying to the hospital. We'll have to close the traffic lanes here on the road. And then we had to also obstruct, where the vans come into this pathology building, bringing in, blood samples and other samples from all over the city for testing. And there's an electron microscope here. So I'm just giving you the context of the complexity. There's road, we have to construct in the hospital. And then if we had followed that concept, we would have to close down or shut down the hospital services. We had to close and obstruct the traffic here. and there's a heritage listed wall which we had to demolish. So if we look at the pictures inside, which shows the value engineered solution, which is the right side, which we actually came up with after applying a lot of value engineering concepts. So as you can see in the pictures, we had to, and that's where I'm talking about the project challenges, we had to maintain this footpath. I mean, if we go around Jakarta, we see a lot of footpaths are actually where, you have motorbikes parked, or, there's a bridge, pedestrian bridge coming in, which actually blocks the footpath, but we had to maintain this footpath and still construct our bridge and the bridge columns. And that's on the right hand side is, you can see the traffic was going all the way through. So what we then did is we changed this original concept and what we did was came up with this right hand solution. And what our challenges was to clear the footpath width, keep it clear. And then the services which are going through this footpath, underneath the footpath here, we had to make sure that they are not affected by our construction. So we had to design the bridge in such a way that we can keep the services, which is electricity, water, gas, and all that in there without getting affected. This wall which you are seeing, this is a more than 100 years old wall. We were told that you are not supposed to touch this wall at all. You need to keep it as it is. And if you actually literally affect this wall during construction, you have to put a number on each and every stone and make sure each stone goes back where it came out from. And then inside the hospital, on the left hand side, which you can't see in the picture, we had these tunnels, which we'll see in a minute, which we had to keep unobstructed. And this is the hospital building, where you have got people and working in, doctors, patients who wanted their view not to be blocked due to this bridge right in front of them. So what we did, again, there was an electron microscope in hospital building. We were told that no vibrations should be transferred to that electron microscope because it's very, very sensitive. So during construction, if you are drilling a pile or something, and even during the operation of this bridge, when the vehicles go on this or bridges or buses go on this, there should be no vibration which should be transferred to the electron microscope. And then, as I said before, a section of the bridge goes over railway tracks, it goes over another main road. And then what we were also asked is to keep the hospital functional. And also, if there's a fire, there should be fire brigade, which should be able to come inside the hospital. And, also we need to make it look nicer. So these were some of the challenges, all of them in one place, which we have to solve. And hence, we said we can't use the original design and we have to value engineer this and come up with a new design, which will help us with meeting all of these challenges of keeping the footpath width, not affecting the services and, provide access, etc. So as we said before, what can value engineering help it with? So, I mean, it can help us in solving problems. It can help us in reducing the cost. It can help us in doing the construction faster. So in the section, in the picture, we were looking at the footpath, which is underneath this, if you see in that plan. So normally, if we are constructing a bridge, the columns which you are seeing here, they are actually not in this direction. They are actually parallel to the beam above. But because we had to maintain the footpath below clear, so we decided, okay, why don't we value engineer it? So we rotated the columns 90 degrees. So actually they are now parallel to this, and they are not in the center of the bridge as well. They are actually on one side. So we again still have the same problem of, the bridge trying to fall over or overturn. And then because of this very, very huge bending moment, which is the bridge trying to overturn, if we had used normal piles like this, where, your structural capacity actually comes from the steel reinforcement bar, which is as far away from the center or the neutral axis. So if we had adopted this section, we would have to, actually literally fill all of this space with reinforcement bars because of the huge moment which is trying to make this bridge topple over or fall down. This was not work. So what we did was, okay, how about, first of all, we have rotated the column this way and then the piles below these columns. What we did is we said, how about we drill two piles next to each other and drill the the space in between as well. So we actually come up with this very long, elongated type of pile. And by doing this, all of these steel reinforcement bars, if we compare above, where it's only 1 bar or 2 or 3 bars which are giving us the maximum capacity, all of a sudden we have all of these bars which are away from the center of the pile, giving us a lot more capacity with a lot more steel area away from that. So by doing this, we were able to reduce the reinforcement, which was about 6%, to about 1.8%. So again, a huge saving, but also we also achieved the other aims of not encroaching on the footpath. So we left the footpath in place. We reduced the cost because all of a sudden we are using much more reinforcement into the column and also into the pile below. And then also because we did not relocate the services, we leave them in place. Because what we did is we are drilling only in this area. So I'll go to the previous picture. So I mean, we are effectively leaving all these services here. We had to relocate all of these for constructing this foundation, but we left them in here. We used a temporary steel casing or liner and drilled the pile through this. So there was no impact at all on all of these services. We didn't have to relocate them. We kept them in place. So, it saves us time, it saved us cost, but also, as I showed you before, it also helped us in reducing the steel reinforcement with the value engineered solution we adopted. So it solved our problems, it reduced the cost, and it reduced the time as well. But then what do we do? And because then this arrangement we have, and then we still have to have this beam, which you are seeing here before, on top of which we are going to put in our bridge beams, which go along the span, which I'll show you in a minute. So, we had to again reduce the weight here. So we said, how about rather than having a horizontal, very deep of this pier cap, how about we taper it to reduce the weight? So we use pre-stressing, but we reduce that moment which is trying to overturn and make this bridge fall on the road significantly by reducing the weight. And then this is a complete picture of what we were looking at before. As I said to you, this building has an electron microscope. So what we did was we actually came up with a floating bridge structure, which means we used very, very small spans so that, big spans mean big forces going down and going in, but also we use thick bearings, and all of this is all the way through. We have not actually tied the bridge to any of the columns below. We're still restraining it laterally. For example, if there's an earthquake, so it still doesn't go and fall down either way. But we reduced, as I said, the weight here by tapering this. It also gave us the vertical clearance which we required on top of the road below. But also, as you see, we have taken off some beams here as well and try to reduce the weight. So, I'm sorry, it's a very technical sort of presentation, but I wanted to take you through the concepts of what you can do. We can design a bridge or a structure in any way, but if we pay attention to different aspects, we can solve all of these other problems which we were looking at before. So, I mean, by doing this, we actually also kept all of our construction outside of the heritage listed wall, which we were not supposed to touch. We did not have to demolish this tunnel where all of these blood samples and all that come into for checking into this building. So we did not actually impact on anything. The road access was maintained. All of our construction happened outside. We were able to maintain the footpath width. We did not relocate the services. We saved steel. We got looked at this and this moment which is trying to make this which is trying to make this bridge topple over and fall on the road on the right hand side, this Bowen Bridge Road. We reduce the weight. We take off some beams from here so that we reduce the weight further. And then we looked at the reinforcement bars as I showed you before. So this is just a high level view, but like there were so many constraints in this that we had to actually think about all of the things, maintaining access, not relocating services, etc. Plus there was then the complaint about you are blocking the view from inside the building. The doctors and the patients, they will see a big wall in front of them because we had to put in a noise barrier or noise wall here. So we thought about that as well and said, okay, what do we do about this? And also there were worries that if a bus catches fire here, it can affect the hospital. And if there's a fire in the building, it can affect that. So we actually put in a fire trencher system, which is a pipe which goes all along the length of the bridge for protecting it from fire. Again, a lot of value engineering going in, which is saving us time, which is saving us cost, which is also solving all of our problems. So going further, again, how do we save costs? So we try to standardize everything, which means, for example, if you look at these, all of the spans are equal length as much as possible. All of the columns are same dimension. All of the beams are the same dimension. We even try to keep the steel reinforcement bars the same. So there is easy way of checking what we have done because there's a lot of repetition. So once we have checked, for example, one drawing, it means all of the drawings for the other spans are checked as well in terms of, so it saves a lot of time, it saves mistakes on site, but also it helps the contractor because they can use the same formwork again and again and again. So it means they save a lot of time and cost in terms of, assembling new formwork. So a lot of cost saving again, and also a lot of time saving. And then again, as I said, this is an old project, but because the reinforcement was very complex, so we did 3-dimensional modeling of the reinforcement, and that is like 15 years ago, and we drew different reinforcement bars in different colors to make sure that we can easily see whether there are any clashes, how much clear space we have to put in so that concrete can be poured and vibrated. So we looked at all of this constructability as well as part of our design. So that helped a lot, that helped in construction, that saved time for us to design, that saved time in construction, and it saved cost, and it solved all of the problems I talked about before. Okay, so I was talking about this right outside the hospital. If you look at the picture and, the people inside the buildings, they wanted to see outside, and they said, you're blocking our view. So what we did was, for the noise wall or noise barrier, we actually used toughened glass. So these barriers are made of glass, so there's no obstruction of view. People can see outside, and we are not blocking their view. Then there was another problem, if we put street lighting, which is normally done on poles, high poles which go up, again, that would have put in glare inside the building. So we said, okay, we don't want to do that. How about we install the street lighting on the barrier so the bus drivers can still see the road below, but the lighting actually is not going into the hospital building. So the patients and the doctors inside are not affected by the light from the busway. So again, looking at value engineering, trying to solve problems, but also improve functionality. So I mean, you're using a noise barrier here. So it's of course minimizing the noise, but at the same time, it is actually also solving that problem of not obstructing the view. And we've just talked about the lighting. Then in terms of, we had to improve aesthetics. So we said that we will use precast concrete barriers. So the traffic barriers, which are here, were actually made precast. So if we do it precast in a factory, it actually is much better quality rather than we place the concrete on site. So as you can see, very nice appearance. And you may be wondering, why are these lines on the outside? So obviously this is a hospital for women and children. So what they have tried to show is, like, these are boys and girls. So these are X and Y chromosomes, which they have shown to highlight that this is outside a women and children hospital. So this is where the patterns come from. And then the space below, it was looking quite ugly, and there were holes and all that. So we use aluminum cladding, and that aluminum cladding, we actually again tried to show that it's a hospital. So you can see some doctors here. So it's all was well thought through. So not only are we saving costs, because if we try to make concrete here and try to make a lot of patterns like this, it's expensive. So we come up with a easier, cheaper solution of using a very thin aluminum sheeting, but it hide all of the bad things behind, and it make it look nice. And you can see the wall below, we didn't touch it, so it was maintained. So we didn't have to take each stone out because it's heritage listed and put 1, 2, 3 number and put it back. So as you can see in just one section of this project, how much value engineering has gone in and how we have solved the problems, how we have tried to reduce the cost, and how we have tried to reduce the construction time. So again, I mean, at that time, we were looking at the reinforcement we saw before, sorry, the other way around. So this reinforcement, we now people use BIM, and we use Rivet, and we use other Tekla structure and other softwares to do this, but that was done just using 2D CAD at that time, and we still looked at constructability and other things. But at the same time, even though nobody knew what BIM was or what BIM can do for you, because this was right in the center of the city and very, very busy with, we talked about this bridge going over railway tracks, which are here, and the roads. So we actually did three-dimensional modeling of whatever technology was available at that time. So we wanted to check if we use a crane and bring in this beam, which is precast, whether it will actually fit onto the span or not. So we use the 3D technology or 3D modeling to actually check our construction and installation tolerances. And also we developed a tool, which is again a three-dimensional display, which I will share with you a bit later, where it was developed for two purposes. One is for, there were lots of stakeholders, including the hospital, there were other, commercial tenants, like, there were this is a car park, and there were, everybody wanted to know what the project would look like once it's constructed. Why are you not making it underground? Why it will obstruct view, it will make the city look ugly and not nice and all that. So everybody was objecting to the project. So we had to develop this three-dimensional model to show to them that actually, no, look, it really looks nice. And also that, as I will share with you later, it was used as a training tool for bus drivers. So the bus drivers, before they actually come and drive here, they can actually look at this tool and actually get a feel for what it would be to drive on this project when they are coming on here, going on to the bridge, turning left or turning right, which we'll see. And again, if we talk about BIM 60, at that, in 15 years ago, we actually made use of this three-dimensional model and actually made attributes here. So actually, instead of just looking at the as-built drawings, which we produce as was required, or as constructed drawings at that time, we had cataloged all of the components of the project in that three-dimensional model. So you can click on here, it will tell you, this is a beam, which is, 1.5 meter deep, it is 1.2 meter wide. So actually, in addition to the as-built drawings, you can use this for asset management, because all of this information was electronically put into this 3D-dimensional model. So again, looking at future proofing, making sure that before we start construction, we check whether, we will be impacting on something or not. And also, once the bus driver will drive, once the project is finished, what will happen then? And also during asset management, later on, when people come to do maintenance or want to know what is actually inside, what size of the beam or what is in here, all of that was done at that time. As I mentioned earlier, although this project has been designed for BRT, but the client wanted us to make sure that it can be changed into light rail transit or LRT, or if you say MRT in future. So we had to think about that during our design and construction as well. So now this project actually it's still a BRT, but it can be converted into an LRT with minimum cost and time, because we have already included a lot of provisions in there, which will make changing it from BRT to LRT very, very quickly and easily and at a very cheap cost. So some of the things which we did was, for example, the alignment which we adopted. If it's a road, you can make it very steep. You can go up to 6% grade. But in this case, if you are using a light rail, you cannot use 6% vertical grade. You will have to restrict to 3%, say. And then the curves, horizontal curve here. Normally in road, we use circular curves, but when you are doing a railway, we have to have spirals on both sides of the circular curve. So what we did was, although it was for BRT, we designed the alignment for future conversion into into LRT. So we used all of the aspects of railway alignment in terms of vertical grids, geometry, and even the bus station, which you are looking at, the platforms and all that were actually designed keeping in mind that in future the buses will be replaced by light rail. So some of the things we did, I've talked about. Also, when you are using light rail and in future when you install overhead electrification or third rail onto that for future light rail, we actually already made provision for stray current. Like if a current goes through, because the current can actually corrode the reinforcement will be corroded. So we actually thought about all of this. We welded the reinforcement, and then we put in cathodic protection, and there are points where you can go actually check how much current is this. It was done on very minimal cost. It does not cost a lot of money, but we make it future compatible. So let's say now if the government wants to go and change it to light rail, they would not have to demolish this project and start from beginning. They can just very easily modify this. So again, value engineering in action. Then we talked about, you can use value engineering for minimizing environmental impacts and actually maximizing social benefits. So what we did, again, we now hear about sustainability, and we say, we need to worry about the planet. We are actually causing a lot of damage to the environment and all that. So that's like, at that time, we thought, how about we install solar panels on top of the bus station where the passengers come and get on the buses? So rather than the lighting, coming from PLN or somewhere, we will generate our own electricity. So we installed, this is like 15 years ago, we installed solar panels on top of the busway roof to generate the electricity for the busway itself. Then we said, we are collecting all of this rainwater here. There are toilets in the bus station. How about we collect that rainwater, bring it down and store it into underground tanks underneath the bus station. So this water is then available rather than getting a water supply from somewhere else. Why don't we use the rainwater which we have collected and use it in the bus station where it's required? Then there was all of this empty space left under the bus station. We thought, it's wasted space. How about we think again about sustainability, and we constructed a cycle center there. So that's where somebody can come on a bicycle. There are lockers inside this cycle center. There are showers. So actually somebody can ride a bicycle. They can leave their bicycle here in a lock. They can go to the shower, change their clothes, which they've been using for bicycle, and actually put their stuff in the locker and then go up the stairs or the elevator or escalator and catch a bus. So again, it's encouraging people to do exercise, but also to save on, people trying to go everywhere in the cars or all that. So we even thought of that, and this cycle center is incorporated into the bus station. So there is a creek which passes through the construction site. So we said the water of this creek is brackish. So it's like tidal water which comes from, and see, it's salty. But we didn't want to bring in water from outside for concreting, which we were doing here, or any other water which was required. So we installed a mobile desalination plant to purify the water and use it for pouring concrete and all that. So we did that. Then it was also thought of that, there is construction waste. When we're constructing, maybe, we've got steel cut bars, we've got timber or wood from the formwork and all that. So we separated it out right then and there so that it can actually be taken to the relevant disposal place rather than everything going to a landfill and somewhere and, wastage of the material and all that. And also, as we saw earlier, we try to use a smaller footprint. So, it's not like, we kept the footpath, as I said before, but also not encroach too much on the ground and all that, and keep everything as optimum as possible. The smallest column size, the smallest reinforcement we can use. So we did that as well. For landscaping, we use native plants. We made sure that we get consultation from the plant experts and ask them what type of plants we can grow here, which actually do not need watering for landscaping. So once you plant them, you just need to give them water one time and then they grow by themselves. You don't have to come and do water them all the time. So even we thought about that as well and installed the plants accordingly. I think I'm just getting towards the end, so please bear with me. Yep.
Okay. If you can wrap up the presentation within the next couple of minutes, that would be great.
Sure.
Thank you very much for that.
No problems. So, okay, so I think this is just some other initiatives where we wanted to provide this information inside the hospital so people can see when the next bus is coming, so they can, leave the hospital and come and get the buses. We actually put in some, sustainability panel to give people information how much energy is being generated, how much power is generated by the solar panels, and how much water is stored. So just encouraging people. And yes, the client was happy. We saved $16 million, as I said before. That $16 million was distributed between the government, the contractor, and also the consultant, because that was what was agreed at the beginning. If we save money, everybody will get a share. Because of the time saving, we finished the project 2 months ahead of the program, and the hospital and everybody, nobody had any complaints because we made sure that we coordinated with them. So the client, you saw the client letter, the client was very, very happy and gave us a letter of appreciation and saying really, really happy. We won a number of awards from Institution of Engineers Australia. They gave us the award for engineering leadership and project management. We got award from Australian Institute of Project Management for project of the year, etc. We got awards from the Architectural Institute for public artwork and sustainability. So I think that's the end of it. I mean, I've got that driver driver training tool and sustainable the stakeholders 3D visualization, which I talked about. I would not show it to you. I mean, I'm more than happy to share it separately because it's about 3 minutes long. And so how do we apply value engineering in Indonesia? Just very, very quickly, some food for thought for you to go away and think about. So, I mean, if we have a project in the center of a city or in an urban area, we should, before starting design or before starting construction, we should think about traffic management and suit our design and construction to that. We should try to minimize wherever we don't have to relocate the services like the electricity and power. We should try to keep it there and design around it. Reducing cost, we can use recycled materials. For example, if we demolish a road or we demolish a concrete structure, we can use the material from that as aggregates for new concrete. We talked about standardization of design before. We can even look at the structural shapes, the beam shapes and the column shapes, and try to not use material where it's not required to reduce cost and all that. We can use precast material, concrete. This is all for you to go away and think about. We can use steel sections for faster construction. We should think about constructability, as I showed to you before, and improving functionality. For example, if we have a bridge over a big river, it's not should only be for cars and all that. We can use it for giving opportunity for cyclists, pedestrians. We can carry services like water, etc. on the other side. We talked about fit for purpose solutions, quality. Yeah, that's something which when we're looking at value engineering, we should think about, precast concrete. I talked about, future proofing. We talked about that, and environmental impacts. So I'm more than happy to share these slides with you. If you like, you can go away and take it and read it in your time. So thank you very much. And my apologies if I went for too long, because I think there was a lot which I wanted to share with you. So thank you.
Okay, thank you, Pak.
Thank you very much, Pak Khalid, for a very detailed presentation on the value engineering in civil and structural engineering. So just to summarize, value engineering is not just making a few beams or columns smaller, but it's about looking at the whole picture. So we are way beyond time. So there are a lot of questions, but first we will go through the panelists' comments on the presentations and the inputs. So first we will invite Pak Alvin Temono. Pak Alvin, if you would like to provide your thoughts on the presentations, please.
Still muted.
Still mute, Alvin.
Still mute.
Okay. So, ladies and gentlemen, thank you for allowing me to give some comments on this meeting. So actually right now I'm doing my value management training, so I didn't really follow that presentation a lot, but I can share a little bit about value engineering actually in Indonesia. So I believe that Mr. Hendro and also Mr. Khalid already tells what value engineering is. But right now, what I want to say is this value engineering sustainable in Indonesia? The answer is, until now, the answer is no. In 1980s, there's a project in Indonesia where we do value engineering. It's called like over Cawang. They use value engineering on it, and then in 2006, Himpunan Ahli Value Engineering Indonesia established, but the follow-up on this organization is not that much, and then this organization is not that active because the demand and supply of value engineers in Indonesia is not that stable. Most of the people say that we already do value engineers, so why should we do value engineering like what Mr. Hain or Mr. Khalid explains, where you need some facilitators to do it. That is the problem that we faced. That's why I say that it is not really sustainable. And then in 2007, PUPR issued a decree which states that every governmental building 8-story above must use value engineering workshops. How about the follow-up? We kind of do some follow-up interview with the decision maker, and then the follow-up is that they didn't do value engineering as standardized as international standard. So let's say you do that value engineering and then you ask it to be certified or certified by the international standards. The international standards say this is not value engineering what you do. So we have that problem actually, that our standard on doing value engineering before is not international quality standard. There's also the issue that we found. That's why I also said that it's not really that sustainable if we didn't change our way of doing business in this value engineering thing. But in 2022, we established kind of guidelines on how to do this value engineering internationally correct. And it is translated into Bahasa Indonesia, so don't worry, you can read it in Bahasa Indonesia. And you can find it on Google, so easy. Just type value engineering pedoman Bina Marga. Pedoman value engineering Bina Marga. There it states how to do value engineering correctly, as stated by Mr. Hendro or maybe Mr. Khalid. And then you can make that study certified internationally so that we can have advanced international PE expert. And one more thing, until now, there's only one value engineers from Indonesia that is internationally certified, the advanced level. This is just like your utama level G2. Nah, but this guy is not really practicing value engineering because he lived in US. He was an Indonesian. He practiced in the US. Therefore, I can simply say that there is not really advanced value engineers in Indonesia like Mr. Hain in Indonesia. So there's a problem that we are facing. Yeah, and then also training. Yeah, you can find the value engineering training internationally. Yes, you can find good certifications, and also you can do the e-learning online. It is available. So we can do value engineering study and also value engineering training online. It is possible. So yeah, maybe that's it. Oh, one more thing about value engineering. Yes, we can save costs, but is it implementable? Well, the answer is yes. If you do it according to the standard or the guidelines that we publish in Bina Marga, the savings, let's say 20% to 60%, they are pretty implementable and they are currently under construction. So if the saving is not only on the design stage, but it's also implemented. I think that's it from me. So thank you for this opportunity.
Thank you, Alvin, for that very insightful and very practical response to all our speakers. Now I would like to invite Pak Habibi as the second panelist. Pak Habibi.
Yeah, thank you, Pak Frankie. I should have been a moderator for this today's afternoon session. Unfortunately, I was on business trip. Now I am here somewhere in North Maluku province at mining site, so it's quite difficult to find a good signal here. That's why I was a little bit late joining the event. Yeah. However, I listened to half of the presentation by Pak Hen De Jong, and then we had the full presentation from our Secretary General, Pak Bambang, and for sure, we listened to the explanation on the bridge case study using value engineering approach by Pak Khalid. Pak Khalid is actually also a mentor to me. He's a real structural engineer working for 25 years with SMAC, actually with SMAC International before he moved to PT Arup. So that's the fact that we learned together from SMAC. Okay, I think the first one for Pak Hein, I would like to stress again the importance on the value engineering. Some of the people, our colleagues, they thought that the value engineering is only applicable for construction sector and mostly for the public infrastructure projects such as bridges, highways, and MRT, BRT, all those things. In fact, value engineering concept is broader, can be implemented in the oil and gas, mining sectors, process engineering sectors, even for the manufacturing sector. The value engineering can be implemented, and then it will create benefits to what Pak Khalid mentioned: saving costs, saving time, solving problem, as well as improving the functionality. So I think that would be great to understand, to learn more on the value engineering. Understand Pak Hen having several courses, trainings with regard to value engineering within the Ministry of Public Works and Housing right now. I think you guys running the certified VM2 or VM3, if I'm not mistaken, Pak Hen. So that would be great to socialize more to the participants as well, whether they are interested to join this kind of a program. I think that's for Pak Hen, for Pak, of course, for Pak Khalid, the bridge project. Then it's actually it's not a green development. Yeah, it's a brown development where you know, you need to manage that there are existing public utilities there. Then you need to do kind of design modification to adapt to make sure that the existing utilities are not disturbed. Yeah, it's not disturbing the whole operation line. Yeah. And the question is, for this kind of value engineering that you are doing, Pak Khalid, whether this is done during the detailed design or done in the earlier stage, such as a feasibility study or concept design. And the second one, normally for this kind of value engineering workshop, value engineering meeting, how many people do you need to be part of the meeting, to be part of the workshop? Who is going to take a lead and who is going to be the member of the value engineering committee? Whether you have the VE in-house or you have kind of a external facilitator to lead this kind of a value engineering workshop. I think that's it for me for the time being. Yeah. Thank you. Over to Pak Frankie. Silakan Pak Frankie.
Yeah, sorry, most problem. I believe it ended with questions to Pak Khalid. So Pak Khalid, if you may.
Yes, thank you, Pak. I think very good question, Pak Habibi. Actually, I would say that it is all subjective. So the value engineering can happen at any stage of the project. So it can happen during feasibility study, but the example I used, the value engineering was done during the detailed engineering design, because we had a reference design, which I had shared on the left-hand side previously on the slide, which when we started doing the detailed design, we found was not constructible, would have all those other issues, and it will create a lot of problems in terms of cost, time, everything. So for that particular project, it was done during detail engineering design, but as I said, it can apply to any phase of the project, whether it's feasibility study. It can even be applied to asset management. It can apply to any other stage operation as well. The second part of your question was, should it be done in-house or whether we should get a facilitator? So I think the first important thing is the value engineering should involve different stakeholders. It's not only the designers, because you need people from operation and maintenance stage to be there, because they would tell you what their issues would be. Just like as we saw, we had to think about the ambulances coming in and the fire truck and all that. So there needs to be a multidisciplinary team who should, from their area of expertise, contribute to the overall solution, looking at the big picture. What are the constraints, what are the challenges, and what are the solutions, and whether it could be done in-house or it should be done by facilitator. I think it is again subjective. I mean, if we get a facilitator, it would be good, because they know how to go about it in the right way, in a systematic way. However, the example I presented, we did not have a facilitator, and it was all organized by the project manager, managing all those aspects and making sure the whole design team was thinking about all of these things and adopting the solutions by looking at different options and criteria. Thank you.
Okay, thank you, Pak Khalid. So with that, we will move on to the Q&A session. Everyone can submit through the Q&A button that you'll see, but there are already more than 10 questions here, and they're all good questions. But what I will do now, I think I will select nicely 2 questions per presenter, including Pak Bambang. So maybe I will start with Pak Bambang. Pak, there is a question here. The first one that I will address to you, Pak Bambang, is there is someone asking, how can we learn value engineering in detail in Indonesia? Is there any institution that can provide the training? Now, Pak Haines already answered, yes, PII. That's why I pass it to you, if you can answer that. And then I will have another question after that.
Yeah, okay.
Please, Pak Bambang.
Okay, actually, I have the same question here will be passed to Pak Hein or Pak Khalid. Yeah, since in my opinion, yeah, value engineering team should be attached in the consultant team, start from the beginning of the project. Yeah, not only separate. So if it's separate, then it is a burden to the owner of the project, right? So I don't know it is if we trust to the consultants, if we trust the designer, yeah, which will be which already appointed by the owner of the project or the investors, then we have to think, why don't we attach the value engineer? Why don't we attach the value engineering team into that consultant group? So we don't have to pay, we don't have to spend double, yeah, or twice, yeah, or we engage consultants to design our project, and then given to next team the value engineering, and the compensation to the value engineer is based on the how based on the saving, yeah, based on the saving, they can create as a result of the value engineering activities that they do. And of course, with the condition that the quality and the safety and then the function is not less than the original. Because in Indonesia, as I know that from the Pak Alvin, yeah, it's very difficult because some designer also sometimes when they design the project is very over designed, yeah. So for this stuff is very easy for the value engineering to do the job, because some of the works already over designed, it's very safe, very in structural engineering. If you design based on plastic design and then elastic design, and then you change to plastic design, then it will be safe. That's like that. So the limitation, yeah, the limitation. What is the value engineering is should be very clear, yeah. And then secondly, I think regarding the question from the audience, yeah, about the training. Okay, I think PE will try to collaborate with you to conduct that, try to conduct the training of that, yeah. But basically, I will agree to discuss in more detail with you, yeah. Actually, the definition of the value engineering itself, yeah. How to apply the value engineering in the field, yeah. And then, of course, everybody will happy, yeah. Of course, investors, owners of the project, if they can save the money, of course, yeah, function is okay. So it is a challenge to us, and I will conduct the more discussion, yeah. Basically, the idea of giving a training is okay, and Pak Hein and Pak Khalid probably can help to provide ideas to what should be done by PII in this case, yeah. Okay, Pak. I will accept safely. Yeah.
I have another question. So each speaker will get two. Second one is from Kana Hernama. So I want to ask, what is the difference among organizations, PII and Haki, Hati, EMP, etc.? So I suppose it can be viewed within the context of this webinar or even generally. So Pak Bambang?
Yeah, PII is Institution of Engineers Indonesia, established and run under the law 1114, yeah. But basically, this institution is, according to the law, is has been mandated by the law to carry out the engineering all over the Indonesia. Means that we not only do certify the engineers working in, but from look after from the accreditation from the university, accreditation of the university, yeah, until preparing or supporting university when they conduct the professional engineers, until certification and then issuance of the license to practice. So what will be issued by PII is license to practice. It is the ultimate. The end goal is license to practice. While other associations, is responsible or is looking after the specialities. Yeah, for instance, yeah, Haki is based focus on construction. Hati is geotechnical engineering, etc., etc. So not the whole professionalism or license until the license to practice of the engineer. Yeah. So I can easily explain in bahasa Indonesia, of course. Yeah. If they are the person is Indonesian, I can talk in bahasa Indonesia. Indonesian atau bukan, Pak?
Inggris, tapi ini kayaknya dari orang Indonesia, Pak. Bahasa Indonesia nggak apa kayaknya, karena ini menjelaskan mengenai organisasi.
So very clear, ya. PEE will issue the license to practice, will issue the certificate of professionalism, yeah, which include not only the technical competence but also ethical standard, yeah, and then also engineering practice, yeah, etc. Yeah, but in the other associations like Haki, Hati is more specific in subdiscipline. Yeah, for instance, in civil, their association is focusing on special subdiscipline. So this is the objectives is quite different. Yeah, the Hati will issue the SKA or a certificate of competence, technical competence, yeah, which normally be used by the owner of the project, yeah, to find the special expert, yeah. For instance, yeah, Ministry of Public Works will build a bridge, so they will look at they will look for the engineer who has an expert on the bridge, of course, not a dam, not a building, etc. We call it SKA, ya, surat tanda sertifikat keahlian. But in PEE, we will not issue certificate which to be applied as requirements for obtaining the project, but when you're going to work, then you have to have permits, yeah, permits, license to work from PII. That's the difference.
Okay, thank you, Pak Bambang, for the very detailed explanation of the difference between the organizations and the certificates. So now I will move on to Pak Hein. Couple of questions for you, Pak Hein. So the first one, it is actually you actually already answered in the chat room, but it probably is good if you can elaborate. So the question is again the same from Kana Hernama. So the question is, what is the difference between value engineering and engineering economic? Is it the same methodology?
Value engineering is a very specific process which is described in different standards in Europe, United States. And engineering economy sounds to me, as far as I understand it, engineering economy, which is different from engineering systems and optimizing designs. So if you give me a definition of what you think engineering economy is, but if you want to know what value engineering is, go to the European standard or go to the SAFE International website, that's American Society of Value Engineers. That's my briefest information.
Thank you, Mr. Hein. So second question for you, I think is this is even more focused than that one. So the question is still revolves around that. is there any difference between VE and feasibility study, which looks at IRR and NPV and etc.? So internal rate of return and net present worth.
Yeah, they are different because the value engineering study is a short time intervention, a workshop from 2, 3, or 5 days, usually. And the feasibility study is the design that is to be optimized. So you can integrate value engineering more, but the value engineering activities always, as by the standard, are short interventions. And the next thing you must do is make a great feasibility study. They're separate processes and they have a separate purpose. So the ongoing activity is the feasibility study from start to finish, going over to the detailed design. You must do your best, you must integrate as much as you can, and then the support is for the value engineers to optimize it. Just by looking differently at the design, maybe different people, maybe a bit more stakeholder involvement, maybe more cost and function thinking, maybe different analysis. So the support is the optimization. That's what value engineering is doing. So make a good feasibility study, do it as good as you can, and next improve it with a value engineering study. And one of the tricks for value engineering, you can ask other people to be present for a short while, some days, to optimize it. So you can look with fresh eyes or different eyes from an internal team or your colleagues from another project or an outside team to optimize it. And that's the thing. On a certain moment, you become a little bit blind for your own project. That's, you know, you've seen it 10 times and then you don't see it anymore. That's it. You're done with it. And that's the time when a fresh eyes and a fresh team can start questions, which in the end are going to be very good. Yep.
Thank you, Mr. Hines. So we look forward to the continuing discussion, as Pak Bambang mentioned, about continuing the course with PAE. So the next one, we move on. A couple of questions for Pak Khalid. So the first one is very pointed for structural engineer from Pak Surajin Sucipto. So the question is, when we do VE, who will be responsible for the overall design? The original structural engineer or the VE engineer? So I'm pretty sure you're very experienced in this. Please, Pak Khalid.
I think I will point you back to what a very good point raised by Pak Bambang. Actually, it should not be two separate people. This is my personal opinion. I think maybe it could be a compromise where the actual team which is doing the detailed design or the design gets a facilitator who helps them in doing the value engineering. That would be a short answer. Yeah, I hope it is what answers it.
May I add to it? The explanation from Bambang about certified engineers, they are responsible for a good design. The facilitator as a value engineer, he can try to optimize it with all means. But the engineer himself is going to accept or reject the changes. And in the end, he's responsible. The whole thing is working well and designed well, because that's his expertise. That's not the expertise of the value engineer.
Yeah, I agree. I will just add on to this. So what I was trying to say is the technical solution would still come from the actual design team, but it can be facilitated by someone who knows how to look at the big picture and what they should be considering.
Yeah, if I may add, it usually depends on the contract in the end. Who's the client asking to be to take over?
Yeah, but if you are an engineer and you have got good ideas, and sometimes the contract does not actually not give you the space to do it. That's what I told you about Binamarga. Sometimes they don't give you the room, but you do have the value engineering process. So if you get stuck, you have got better ideas and you know you can improve the value and they only have contractual things, then you can apply their own process, which is an innovation and change process actually, to try to convince them to improve the value. And that's a way to go to innovation. And that's why value engineering can be innovative, because it gives everybody a license to be very creative out of the box.
Thank you, Mr. Hines. So we move on to the next question for Pak Khalid. So again, this is a question for structural engineer. What I want to ask is how to meet VE with the risks that arise from optimizing without compromising the quality. For example, in the concrete itself, if we want to accelerate, we upgrade the quality of the concrete, but it will risk in payment. So is the question clear for you, Pak Khalid?
Yes, yes.
Okay.
It is clear. So actually, when we talk about cost, time is also cost. So if exactly what we are saying here, if we use a higher quality concrete or we use more reinforcement because we don't want to wait for the design to be optimized, let's say value engineered, if we are already doing construction, then the saving of time by being a little bit more conservative still will save you money, because saving of time means the contractor machinery or equipment can finish early, that the labor cost reduces. So it is still saving of time. So sometimes it does happen that way, that on the side, the contractor would say, I am happy to just go ahead and take a risk and do the construction without even waiting for the full optimized design. But you can look at it from a perspective of saving of time. And in terms of quality, value engineering doesn't mean that we are going to cut corners or reduce the factor of safety. The value engineer solution must satisfy all the standards and all the relevant factor of safety. Even if we are looking at an alternative, it doesn't mean that. And we can still do that. The cost could still be low because, for example, if we look at a concrete structure, I think I briefly mentioned that if we look at a beam, we can modify the shape of the beam, or for reducing the weight of the beam or the quantity of concrete, we can introduce a hole in the beam because the reinforcement of steel bars still need to be in the top and bottom of the beam. In the central section of the beam, we don't need those. So there you can still have saving of material. So it's all easy, and it's all can be done through optimization and all that. So not difficult, no compromise in quality or nothing. And it can be faster, which will also save you money.
Thank you, Pak Khalid. So we just got the permission to extend a little bit of the time from Pak Habibi. So there is this one question which maybe all three presenters can chip in to answer. So the question is, you provide a picture about the increasing performance and reducing costs in Indonesian infrastructure since 2016 to 2021. Could you please give a practical example of the value engineering that already implemented in Indonesia infrastructure? Shall we start with Pak Bambang? Pak Bambang? Would you like to respond? The question is, could you give a practical example of the value engineering that already implemented in Indonesia, Pak Bambang?
Okay. I think Pak Menteri, our minister, is acknowledge that how important is value engineering is, and that's why they instruct Bina Marga to start to apply, But whether, as my first statement, whether it is already embedded during the first stage, on the initial stage of the development, or after the design is done, I don't know. It may happen that the idea of value engineering is already embedded during the first stage or the initial stage of the design, or feasibility study. It may happen. That's why, in my opinion, I think, for instance, when you look at the toll road development in Sumatra, that's already very efficient in terms of in the design process, because they don't do the design first, and then after the design, and then pipeline to the next to be tendered, and then next to the construction. This already, everything is done all together parallel at once. So in this case, without value engineering, I think impossible this can be implemented. Yeah. So in my opinion, I think Indonesia had already started. Yeah, even it is the level of the value engineering is not like as described by Pak Khalid Salem. Yeah, what they explained before by Pak Khalid Salim, something which already done, the design is done, and then present to other value engineers, and then to be evaluated, into optimized, etc. So that will be saving, and then etc. Yeah. So I think, but depends on perception of our engineers. Yeah, if I talk with maybe a consultants group, yeah, maybe I have done my value engineering, but we can later prove. Yeah, I think Pak Frankie can, and gentlemen, yeah, we have to check. Yeah, but anyway, I believe that this concept, the idea is very good. So we have to, at least from now on, yeah, we have to educate ourselves that when we design something, when we implement something, we have to think efficiently. Yeah, as long as according to standard, efficient in the space and the materials, in the structural design, etc. Yeah.
Okay. Thank you, Pak Bambang. Pak Hein.
I've uploaded a few leaflets from projects in Binamaga. You can read it. I want to show you one which is in my report now. It was a flyover of Sikip in Palembang. This is an original picture. It was made in 2016. They optimized, the project team itself optimized it. The project, so the design from 2016 was optimized. And they already optimized in 28% cost reduction and still a good flyover. And then they challenged again the value engineering team because someone thought we are not done yet. And that resulted in an additional 21% cost reduction without loss of quality. So did the designers not do a good job? No, that's not the case. In the first design, they did a good job. In the second design, it was a good job. And in the third design, it was a good job. But having a discussion on what do we really need and what else can achieve the same at lower cost is something you cannot do alone. So you must have a good design in, and then you start the optimization to get a better design out. And that is this picture what I show you. And the other leaflets I show you have a similar story. So make a good design, do your utmost best, and then with a multidisciplinary team and a good process, you can start optimizing. It's an optimization process, right? So it's one of the value improvement processes. You must always try to do your best. You must always try to make the best design. And then you use the value improving process of value engineering. So it's on top of. That's how it should work. Yep.
Thank you, Pak Hein. Pak Khalid.
I can give an example of an Indonesian project. It's actually there was an overseas investor. I'm sorry, I can't share the details of the project or the investor. They wanted to acquire an existing project in Indonesia, and that project was under construction. And then they said, well, this project cost is too high. Can something be done about it? And they engaged the team. And the team during the construction of that project, this is about 2016-17 I'm talking about, did actually do value engineering for them and actually said the project cost can be reduced, let's say from $1.2 billion to to $800 million, because as I think Pak Bambang was saying earlier, that the design sometimes is very, very conservative. And I think one point I would like to make here, sometimes our clients, with all due respect, think that, you know, the consultants should be paid a low fee. And well, of course, if they get paid a low fee, they will try to do a lot of copy and paste of design, try to save money because there's still a business, for example. But if they are, let's say, if we take an example of the design fee being 3% of the overall project cost, whereas 97% is still construction cost, if the design fee gets increased by 3 to 3.5%, you might be able to save 10% of construction cost by the engineers actually going and optimizing and having the time to do that. But and there is an example of the actual project which I mentioned before, where the team did get involved and were able to prove to the overseas investor that yes, this project cost can be reduced. So there are examples of that in Indonesia for sure. Maybe not very publicly discussed.
Okay, thank you, Pak Khalid. So maybe just one more question for all three, Pak Bambang, Pak Hein, and Pak Khalid. So that we're not just talking about bridges and roads. And so this question is in water resources management sector, is there any best practices in using value engineering method? So maybe we go back to Pak Bambang first. Pak Bambang, is the question clear enough for you?
Yes, it's clear, but I don't know whether it's. I have no information yet about this. Yeah, and I have no ability to speak to. I have to check the sumber daya area, the sumber daya area, but from the I think in general, yeah, what is mentioned by Pak Hein, yeah, a lot of design done by our consultants, yeah, whether it is state-owned consultant or private, yeah, still very conservative in general. Why is that? Maybe it's the cost is low, or maybe the quality of the engineers, in terms of the engineering, yeah, it's not brave enough, not able to design with the, just like, you know, it's, according to me, it's overpass from Kata Subroto to Kuningan, you know, LRT is very brave. Not many engineers in Indonesia able to do that. Yeah, or there are not many contractors in Indonesia also able to do that. Because what? They are not confident enough. Not confident enough to implement, to design, which is very slim, very high risk design. Yeah, even supported by software, everything there. So if that's why, first thing, I think we have to define what is the criteria or the definition of the value engineer. Yeah, before doing that, I think it's very difficult because so many constructed in Indonesia with very conservative, yeah, indicated from, you know, pillars in the flyover everywhere is too big, not as in the Middle East, or not as in Europe or in Singapore, right? Why is that? Yeah, and then also the the box also so thick, so yeah. So in terms of engineering capabilities, is still needs to be improved to me. This is the first thing that when you want to apply the value engineering. Itu Pak.
Thank you, Pak Bambang, for the advice and the challenge given to everyone here. So, Pak Hein, you already answered, but would you like to elaborate more or have anything more to add to what you already?
I will show you. I will show you what the literature says about the top reasons why projects are why we need value engineer. So it's incredible, but cheaper projects sell better. So in the beginning, you must say they are cheap, and when they become later more expensive, that's okay. Oh, stop this one. Right. We are very optimistic human, and we think overruns or so will be compensated by luck. That's not true. Politics don't want to hear bad news. So if your project is in the political sphere, you can have problems if you say that it doesn't work as they thought it would work. Many companies, they look to their internal side instead of looking outside. And outside are the people who pay for it, usually. The customer is forgotten, often. Focus on control and reporting instead of outcome. So outcome is important, not focus on control and reporting. If you design, I don't say control is not important, but I say that designers must focus on outcome. Well, another one, this is also one. Any design, there are lots of assumptions. And sometimes you have good information, sometimes your information is not that good. But too many assumptions and you go wrong in your design. So detecting assumptions and identifying crucial information is something that often happens in value engineering studies. Sometimes standards are outdated or less applicable. This is a dangerous one and a difficult one. You need good experts to understand standards and to know what their applicability is and when you can have a waiver. In every project, there are some wrong people on the design job. It happens. So that's a good reason why a design is not that good. From people involved, including clients, there can be honest wrong beliefs, habits, and attitudes. But they are wrong. Honest, but wrong. So, final one, poor communication. The bigger the project, the more parties are involved, the more communication is getting difficult. And in the middle, you are trying as an engineer to optimize a project. Good luck. Good luck. That's complex. Our job is complex often, isn't it? And processes that will help you in decomplexing challenges are most welcome. So for me, this is one of the reasons why value engineering works well and why engineers must know it. Thank you, Frankie.
Okay, thank you, Pak Hein. So that's very broad principles on value engineering method. Pak Khalid, would you need me to repeat the question?
No, not really, but I think the question was about water resources management, basically. So I think water resources management depends on what type of project we're talking about. If it is for example, a dam or something, so all of the value engineering principles which we discussed earlier about bridges would apply. We could still look at how to optimize material, how to design better, and it can apply. Value engineering can apply on any project. It doesn't matter whether it's a bridge or not. I think one point I would like to make, I think again, is Pak Bambang made a very good point about, yes, some of the bridge columns look very, very big and all that. I think it's sometimes because we as engineers do not think outside the box. We think, oh, because in Indonesia we have to design for earthquake, and therefore the column needs to be bigger and all that. But actually we forget, the bigger we make the column or the heavier we make the box, the more earthquake force it will attract. So we are actually defeating the purpose. So we need to think about how to make it lighter so that the earthquake force is smaller actually. So I think sometimes we just don't think outside the box or think clearly. So yeah, I think that's where, you know, engineers working together and some guidance always helps. Thank you.
Thank you very much, Pak Khalid. Thank you very much, all the speakers, all the participants, all the panelists for such a engaging webinar. So I think we learned a lot today. The presentation materials will be forwarded to the participants. And also there is a recording in YouTube if you'd like to revisit it. Now I would like to invite Pak Ricky Wargakusuma, the Director of SAPES in PII, to provide a closing remark. Please, Pak Ricky.
Thank you, Frank. Yes, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you for all the participants. Until now, is still 119 participants. I think the topics is very interesting, and then the all participants, I believe, also enthusiastic to learn, including me. My name is Ricky. Now I'm the director of in PII. I'm director of CHAPES. CHAPES is Center for Engineering and Industrial Policy Studies, who appointed by Pak Habibie to handling and then to make the the follow up of value engineering and can implement it in PII and Indonesia. Maybe that's, I don't know, this right or not, Habibie. That's why CHAPES become one of the committee in here. Thank you, by the way. Okay, today I also learn. This is not the committee asked me for closing remarks, and I try to make wrap up things, but for me, it's not only conclusion, but this is today I'm learned so much from Pak Hens. Thank you, Pak Hens. Last week I have the private session with Pak Hens to learn about the value engineering. With that 2 slides from Pak Hens about the cycles of the value engineering and the formula. Value is the function multiplied by perform and cost. Make me easy to learn about what is the value engineering. My background is chemical engineers. Today we learn a lot of the sample from civil problems, civil engineering problems, but the idea is still make for optimization and others is make all of the engineers fields how and what's the important about the value engineering. From Pak Bambang, we learn also about the spirit of law 11/2014, and then how to make the competitive and the competent engineers in Indonesia. From Pak Khalid, thank you. We know how value engineers can implement how to solving problems, reduce costs, reduce time. And also from Pak Alvin and Pak Habibie as a panelist, we know Indonesia already started about the value engineering with from Bina Marga, and Pak Habibie remind us not only for civil, we can implement for others. For me, this is like this topic is upon our eyes to be the better engineers in Indonesia, like the wake up call, and maybe it's better I call this a recharging. We are the engineers, daily engineers. Yeah, we understand we can do everything in its fields, our fields. Like Pak Bama said, maybe the conservative one, but hey, wake up! This is have the you should be the better one with the try understand how to reduce costs, how to make all the effective one. I think one the statement of Pak Bambang, I believe this is the important one. We need make the new character of PII members to be the confident engineers. Maybe this one, the value engineering can be one of our instrument to be the better engineers. And then maybe in chips, also with Pak Bambang, we will formalize what is the value engineer for Indonesian, and then how do we appreciate it with the, I don't know, the award or something like that, and then to say that our engineers already implement the value engineerings, and then we can be the climate, the new climate for engineering in Indonesia. Maybe the last one I want to like in bahasa with for Indonesian engineers. Kita jadikan momentum mengenal value engineering ini menjadikan satu momentum untuk kita melakukan perubahan yang cukup mendasar. Sudah banyak mungkin di bidang-bidang lain, kami di industri kimia juga mungkin sangat mengenal mengenai optimalisasi dan lain-lain. Tetapi dengan kita bisa menggunakan value engineering ini menjadi satu karakter baru sehingga kita menjadi insinyur yang lebih percaya diri. Mungkin tadi Pak Bambang menyampaikan itu. Jadi marilah kita sama-sama mengformulasikan ini dengan lebih baik agar kita menjadi insinyur yang lebih baik. I think that's all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Pak.
Waalaikumsalam.
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 Silakan Pak Franky.
Pak Franky.
Makasih Pak Riki. Terima kasih semuanya. Oh, sorry, I'm somehow I switched to Indonesian. Thank you to everyone. So this has been a very eventful webinar, very engaging. A lot of things that we learned together here. We really apologize for the technical glitch that happened in the beginning. But with this, I think we're still pretty much on time. It's not 6 yet. So Pak Prastiwo, would you like to take over?
Yes, thank you very much, Pak Franky. So we are at the end of session. So thank you, Pak Bambang Guritno as the Secretary General, and Pak Ricky as Director of Chips, and all these distinguished speaker, and also the panelists from Pak Habibie Razak as Director Executive, and Pak Alvin, and all the participants. Then after this webinar, the certificates and the material will be distributed to you all. Then see you all at the next season. Thank you.
Thank you.
Bye-bye.
Can we take a photo session?
Okay.
Okay, can we take a photo session? Thank you.
Just take a photo session, yeah, in the closing event, yeah. Okay, just open the video. Silakan, Pak Imam.
Okay. 1, 2, 3. Okay. Thank you.
Bye, everyone.
Bye-bye.
Yeah, thank you. Bye.
Bye.
Bye.